Hello, so my name is Colin Bell, and I am embarking on a new project. And this project is probably going to take roughly 1 to maybe even 5, maybe even 10 years. So it's not something that I'm going to do in a night, that's for sure. The project is I'm going to build my own operating system from the ground up and hopefully even be able to implement a graphical user interface. So I was inspired by or influenced by TempleOS, which was an operating system written by a schizophrenic programmer who was told by God that he should write this operating system from scratch by himself and make it biblical themed. And his operating system included a compiler for his language called Holy C, which I find hilarious. And he built the kernel from scratch after he wrote that compiler. And then he also added a graphical user interface to it. It's really fucking ugly, but at the same time, he wrote all of these games, and it's really just like a unique piece of software. And it took him a lot of effort to do it, and I think he learned a lot from doing it. And I just want to do this myself. So, I have purchased the domain name CathedralOS, and so in keeping with the biblical theme, even though I'm agnostic, I'm going to produce CathedralOS. And this is kind of a play off of the essay by Eric S. Raymond called The Cathedral and the Bazaar. And basically, he considered two different types of two different models of software development. The Cathedral model, where where source code is released. It's built from the top down, and it's released only once every so many days. And it's basically controlled by one person, one like leader, one company, one group. And then there is the Bazaar model, where there's a bunch of marketplaces where each individual person produces a small chunk of the complete picture, and each chunk relies on the other chunks, and it's like kind of like an emergent sort of process. Now, I like cathedrals more than bazaars. Here's one of the most beautiful cathedrals that is currently in production. You can see it's still being built. And the level of intricacy in the design is absolutely just gorgeous. So the stuff in the brown here is what's already been built. So you can see that that's what's already been built. And then the stuff in the white is what is going to be built. So from this design, you can see that it is actually going to be twice as tall in the end than what it is shown here. And like I said, there's just amazing art on this cathedral. It looks like an acid trip. It looks like something someone would design or see in some like alternate alien universe. It's really gorgeous. And then for comparison, this is a bazaar which basically just sells a bunch of consumer goods, and I consider it ugly. I used to live in Cambodia, and I went to their markets, and I found them to be lacking. I did not like them at all. And this is the Grand Bazaar. I guess it's the most beautiful and best bazaar. So this is a paper written by I think one of the leaders of the FreeBSD operating systems, Paul Henning-Kemp, A Generation Lost in the Bazaar. And if you don't follow Paul Henning-Kemp on Twitter, I suggest that you do. He is the author of a lot of FreeBSD, and he really is a cool person to follow, even though he's kind of getting political right now. So I want to read just a section of this paper real quick. He's discussing Linux specifically, or rather parts of Linux that he's wanting to port to FreeBSD or something like that. So modularity and code reuse, of course, are a good thing, even in the most trivially simple cases. However, the CSIT dogma of code reuse is totally foreign in the bizarre. The software in FreeBSD ports collection contains at least 1,342 copy and pasted cryptographic algorithms. So instead of forking these things, these bizarre marketplaces, each individual copies and pastes sections of code. If that resistance/ignorance of code reuse had resulted in self-contained and independent packages of software, the price of the code duplication might actually have been a good trade-off for ease of package management. But that was not the case. The packages form a tangled web of haphazard dependencies that result in much code duplication and waste. Here is one ironic example of waste. Sam Leffler's graphics/libtiff is one of the 122 packages on the road to www/Firefox. Yet the resulting Firefox browser does not even render TIFF images. For reasons I have not tried to uncover, 10 of the 122 packages need Perl and 7 need Python. One of them, devel/glib20, needs both for reasons I can't even imagine. So basically he's saying that Linux is a clusterfuck. So I want to implement my own OS. And there's other reasons besides Linux being, I guess, lacking. Not that I think I can build a operating system that is better than Linux. Let me get back to myself. But I do think that I could at least make an attempt and maybe expand my knowledge of computer software. And I really want to, let's see. It says I want hacker fame. Like, I want to be known as someone who could implement a project like this. I want to be able to do this. And I want to know the details of my operating system fully. Like right now I'd have to go to a book and learn how Linux operates, but if I were to program my own operating system, then I would know how all of it fits together because I built it. And that's, of course, not accepting the idea that I would probably forget half of what I wrote, but at least I would know in a generalized form how the operating system works. Okay, so I'm going to write my operating system in a Lisp. Not Common Lisp, I'm going to write my own Lisp. And the reason why I want to write a Lisp is because it comes in this weird parenthesized form. This is a factorial implementation. And the thing about Lisp is that it relies heavily on lists, which are just basically a bunch of symbols and atoms and objects inside of parentheses. So a single parenthesis denotes the beginning of a list. And so this list contains the symbol defun, the symbol fact, a list which contains only in, a list that contains this if list, and that's it. And the cool thing with Common Lisp, or with any Lisp, is that the code is written in list form. So one can take these lists and rearrange them and basically write their own language from scratch, or build their own language on top of the language. So Lisp is like a meta language of sorts. And this isn't something I can delve into right now and explain, but you should really read some essays about Lisp and start hacking Lisp, and at some point you might understand what I mean by Lisp being a meta-language and why someone would want to write their code in this form of lists, which is called S expressions. So this is like creating a linked list here. You have the function name first, then the arguments. So this is saying link 1 to whatever the result of this is, and this is the function cons, which says link 2 to whatever the result of this is, and this is the function cons, which says link 3 to nil, which lists are nil terminated in Common Lisp, and so that creates this list. It's a linked list. One thing that I find lacking right now in Common Lisp is the word order. So most languages that we use today use subject, verb, object. I ran to the store. That's not an object. I gave it to Sally. I cycled to work. I'm still just using prepositions, but you get the point. You say the subject first, and then the verb, and then the object. And I think the reason why this makes sense is because the subject is something that's usually concrete, and it limits the amount of abstract verbs that can follow the subject. So this resembles Java's object-oriented programming, where you have the var, which is the subject, and then the method name, and then you have the objects inside. And so that's very English looking. Whoa. Okay, so the next style of, I guess, linguistics is verb, subject, object. So that would be like I, it. It's obviously in English it's not going to sound correct, but in Common Lisp that's how we code. Even in object-oriented programming, the object, the instance, comes after the verb. So here they create a class just called myClass, and it has an element x. And then they create a method on that class that specializes on that class called squareX. And so when they call squareX, they call the verb first, and then they pass the instance. So in Java, this would actually be instance.squareX. And so the problem with this is if I'm writing this sequentially, like I'm just typing from the left to right, and I start to type in S for square X, in Java, I would have had instance there first, and so it would only show me the functions that start with S on the class instance, the member functions. Like you see here, system.out. It's not going to show all the P functions for every single object. It's only going to show the P functions for system.out, that object of sorts. It's a static class, but you get what I'm saying. It's only going to show the methods for a particular class. Whereas in Lisp, that doesn't happen. The autocomplete picks from the entire namespace, and it's bad. To me, it's just, I guess maybe pro Lisp users, like people who didn't just learn a year or two ago like myself, may say that I need to better separate my namespaces such that this doesn't happen. I'm sure that's what the creator of Clojure would say, because he's really big on the namespaces. I just don't like that idea. I want to create a Lisp that has the Java calling syntax. So that's something I'm going to change about my particular version of Lisp. Okay, so I have a plan set up to make this OS, and I just want to quickly go through what that plan is. So the first plan is the reading and planning plan, and then I will implement afterwards. So first I will read this book I'm currently reading called Lisp in Small Pieces, and it's going to teach me to build a Lisp compiler. So this is where I make the language that I'm going to build my operating system in. So I am going to build this compiler, but I'm just going to plan it at first while I read. And then I'm going to read operating system concepts. This is a book I started in college but never finished. So I'm going to read this, and then I'm going to make some decisions about my kernel. just still in the planning phase. And then I will read the programming, or the Linux programming interface, which will discuss all of the API calls. And so Linux is a POSIX, which means that it's a portable operating system interface. So the operating systems can all be different, but they use a common interface with common API calls. Which makes it, I guess, kind of cross-platform. I'm not going to use POSIX most likely. I'm probably going to invent my own sort of API for the system calls. And then finally, I'm going to want to implement a GUI on top of all of this. And so I'm going to read a basic book on computer graphics, and then I will write a simple GUI. I'm actually going to try to make it usable as a daily driver, so I will probably try to replicate something like GNOME or something like that, which, yeah, it's a massive undertaking, but I think given enough time I should be able to achieve that. So there was a final tab that I was going to show you, but I kind of became scared to show it to you because building an OS is kind of crazy in and of itself, but building a browser is actually more difficult, I think, than building a operating system. And I do want to build a browser engine on top of my operating system if I have enough time. Because I really actually do, if I build this thing, if I'm successful, I will want to use it as a daily driver. And that is going to be a challenge. So like I said, this is probably going to be a 5-year project. And it's going to be a long slog, but I really want to achieve it, and I'm going to be making weekly videos about the progress that I make in this. And right now I'm working on planning the compiler and planning the language that I'm going to be building. So anyways, this is the first episode of my CathedralOS vlog, and I hope you follow along.